All right, ladies and gentlemen, if I could have a big round of applause for my next presenter. How about you put your hands together for Bryan Heden?
Hi, guys. How many of you guys have a small to medium size Nagios installation? Okay. We had some problems. I'm sorry. Let me back up. I'm Bryan. I'm with Agile Networks. I do the Nagios monitoring there. And this presentation is kind of about the problems we overcame when we went from a small to a medium-sized installation. All right, so here's the agenda. What we do as a company, and so what we needed as a solution, what we customized and configured, some of the I/O issues that was pretty big that we ran into, all the things we offloaded, and some detail on those. What did we learn? Things like not upgrading a production server on a Wednesday afternoon, similar. And then where are we going to go next? So who we are. We're a telecommunications provider. We engineer and operate the Agile Network, a general purpose backhaul network with last mile agility. We get communications to people who are in areas where fiber and copper aren't available. We serve the public sector, oil and gas. It's pretty big in Ohio. Underserved communities where broadband's not available, and enterprise customers. These are some of our examples. I don't know which one of these companies operate out here in Minnesota. I know that the Ohio DAS probably does not. Toys for Tots, probably a name that you guys can recognize. A lot of these things are local to Ohio, but they're pretty big names where we're at. What we needed a general insight into just overall network health, which I think a lot of people can relate to. We needed to see what was going on. We needed to maintain our service level agreement with customers. We needed to react to network downtime as fast as possible. The government definitely does not like to wait, so we needed to accommodate that. And we needed to monitor our traffic across the network. We chose Nagios XI because it was an easy to use and understand interface for the engineers, the network guys that don't have like a techie background. They got the interface, and it was easy for them to point, click, and add things into the configuration. No more text-based configurations to manage. Yeah, that's funny. And it was built on top of something that we were already comfortable with, which is Nagios. I have some experience with Core, and so it was kind of a no-brainer. It worked, but not exactly how we wanted it to. These quotes here, what do you mean it doesn't automatically translate OIDs into human understandable English? That's, my boss said some things. That guy right there, actually. He said these to me when we started the installation. Ping worked, and there was a lot of things that we needed to customize in order to get the functionality that we desired. If you build it, the engineers will use it. We wrote our own configuration wizards for each different type of device. So as a telecommunications provider, we do microwave communications. So we have some point-to-point, point-to-multipoint, a lot of routers, a lot of power, GPS utilities that there weren't plugins available for the hardware that we were using. And like I said, back to we needed an easy interface for the engineers to use. So we wrote the configuration wizards that build all this stuff so that whenever they add a new device, when they provision a circuit, they can go in and they can use those configuration wizards, and everything's just easy. We built some maps. Executives love maps. They like seeing everything, and a lot of the engineers use that also. So I'll get to that. One of the maps tracked the health of devices, links between sites along with like a custom radar overlay. Now, I know about NagViz. It didn't have exactly the functionality that we desired, so we built our own. And another map, when doing the planning for the provisioning of circuits that are involved in the microwave communications, we need to be able to track the frequencies in surrounding areas so that nothing conflicts. And we were using a third-party solution that didn't work very well, so we made one of those too. This is our NOC overview map. This is the first map that I was talking about. So it provides our team's insight into the health of all the nodes and the connections on the network. You can see some of the radar. I would love to be able to log in and show you guys this live. It is animated and the lights flash, and it's really cool. Executives love it. But public safety deems that I can't do that. So you'll have to go with the static image for now. I'm sorry. So anyway, we have everything segmented into host groups, and I wish now that I hadn't cut the screenshot. We have some tabs in the upper right-hand corner there where our network engineers can go in and they can either import geographical information that we have, latitudes and longitudes, based on the host groups, which they already had that information. That's nothing new. And then we obviously put that on. We overlay that on top of a Google map, and the host groups that they link that geographical information to, those are things that are built automatically based on names in the configuration wizard. So they, group name and then whatever the host name is, and it automatically puts those things where it needs to go. The links between here was important for them. They needed to see which port on which router in which host group links to which port on which router in another host group. So that's all static information. It's things that they have a tab, like I said. I wish that I would have included that in the screenshot here. They can log in, they can click, they can add, and it's really easy. I limit what they can see based on which host group they want to go to and which one they want to go from. It limits to which type of devices we allow for the links. So we can limit that to the routers, which we normally do, or if they have a microwave link that they want to monitor, they could do that also, as long as that's a port or a service on a host in a host group. This is the frequency map. Again, I had to black out some of this stuff. You guys can't see my frequencies, I'm sorry. Not that you can even tell where that's at in Ohio, but I say Ohio, I mean West Virginia, yeah. So they can see from a central location the health and operating frequencies of the equipment. So when this map is loaded, it actually probes for those OIDs that we've deemed are responsible for the frequencies, and you can see in real time. By real time, I mean if they want an updated version, they can refresh the page. It's not very CPU intensive or anything. It probes the information, puts it on the screen. The links that you see here, those are the microwave links. I haven't linked anything with the physical, the status links that I was just talking about between services. They didn't really need it. So we have, some of these sites have a lot of sectors that have a lot of different frequencies on them, and this has really helped a lot with how they plan and how they provision the things before they get out to the field without having to call back to the NOC and say, hey, I put this information in wrong. What do I need to do? And eat up a lot of man hours that could have been done right to begin with. So we did that. We accomplished what we set out to. More pictures. Here's one of the configuration wizards, and these are. I made them so that I'm hands-off. Oh, it even says that right there. I should have read it. My custom-built configuration wizards keep our teams working on what they need to and allow me to be hands-off with system additions. So I don't have to sit there and approve anything. The configuration wizard is built. It's pre-vetted in pre-production. And so I know that when I push it to the production machine, when they add an IP address, if they are using the right configuration wizard, then it will pass. If it doesn't, then it fails. It alerts them why it failed and can point them to use the proper configuration wizard. For example, if they go to set up a point to multi-point and they use a point-to-point configuration wizard, that's going to fail because those OIDs aren't specified for that device. It's not going to operate on the same anything. So it tells them that. Anyway, so they put their IP addresses in. I do some probing with SNMP to find out the system description, and then based on that, I have a table that I look it up in and see which device and which OIDs need to be mapped to it. Standard uptime. And then we're going to get into MRTG and some of the issues that we had with that. And I'd like to say, before we get there, just on this picture, the bandwidth and port status. So that code was taken from the router and switch configuration wizard. I don't know how many of you guys are familiar with that. And how it works. It works. We ran into a vendor that the default code for the routers and switches configuration wizards didn't work, and it needed a pretty extensive rewrite. So I ended up rewriting most of that code so that MRTG can scan how it needs to with that specific vendor. And if anybody has any, I'm not going to name the vendor up here, but if anybody has any questions or anything about that, I'd be happy to answer them. Later, not right now. So anyway, we scan for for what ports are active on the machine. And in the case of the radio equipment, I mean, that's usually pretty simple, 1 or 2 Ethernet ports, 1 or 2 radio ports, and we can monitor the bandwidth over those. As far as the routers and switches go, you know, you saw the map, that is our network. So we have a lot of routers. There's at least one at each one of those sites. And as far as logical ports and physical ports go, it gets pretty extensive. I'm going to get into talking about what we went from as far as services go and what we're at now. But probably about 65% of our services are bandwidth. And so that means that our MRTG installation is pretty large, considering everything. And that was a hassle, getting everything to be managed properly by MRTG. Like I said, we'll get to more of that here in a minute. We definitely stress tested in production. We reached our maximum occupancy of what the systems we were running could handle pretty early. I'd say in February, March, we were at about 3,000 services. These pictures were taken for the service status summary and the host status summary were taken about, I don't know, 2 weeks ago, the screenshots. So we've expanded pretty considerably in that amount of time. And the existing server setup that we had wasn't meant for active checks for this many hosts and services. And it may seem obvious to a lot of people. It was not to us. We didn't know. We thought that it would have scaled automatically, and we obviously ran into some roadblocks with that kind of mindset. We introduced ModGearman into our installation, to our environment. We offloaded MySQL. Things got better, but we still had some problems. I/O is a major factor. Again, it might seem obvious. I think at this point, we really weren't aware of all of the database communication that was going on with Nagios XI as we increased the amount of checks that we were doing. Not only that, but performance data processing was a pretty big deal. As you expand the services, obviously performance data increases. When I say that we reached the maximum occupancy on our hardware, we were running virtual machines on an ESXi host that had a RAID 1 15K drives, and that wasn't enough throughput for what we needed. So there were suddenly more host and service checks than we could handle with that setup. 10K drives, I'm sorry, in a RAID 1. Bandwidth, because of the size of our MRTG installation, the process was taking longer than 5 minutes to complete. I don't know are you guys familiar with how MRTG works? Show of hands. Okay, so the default cron job runs every 5 minutes. It starts that MRTG process every 5 minutes, and then if it's still locked when it goes to start the next one, it just doesn't run. It errors out. So our bandwidth was only graphing once every 10 to 20 minutes. So what should have been every cycle, was every fourth or I think it was actually higher than this in some cases. We ended up upgrading the ESX host drives to a RAID 10 6 by 15K. We upgraded some other stuff too. We actually got a whole new box. This was by far the single most important decision that we made, was to get that throughput higher. We didn't stop there. I offloaded MRTG. So out of those 13,000 services, I said 65%. I was guessing. I think as of the last count, active bandwidth checks is probably at around 8,600, something like that. So we set up an NFS share on varlib MRTG so that Nagios could read from it. And we set up an NFS share for Etsy MRTG so that Nagios could write to it. Now, if you remember back when I was talking about those configuration wizards and some of the stuff that I rewrote and how it gets that data to MRTG, I'll go into a little bit more detail in a second. We put both these virtual machines on the same host. After a lot of testing, the NFS latency wasn't a big problem. I mean, that might change when we add another 13,000 services. We'll deal with it when we get to it, I imagine. MRTG definitely had some issues of its own. When they upgraded to, 2.17 is the release of MRTG with XI 2014. Is that accurate? Or 2.16? Whatever the new one was that was able to split the configuration files. That helped a lot, but it didn't help enough. We were still seeing some issues with the processes being locked and not running. So I split the cron job into separate processes. And it stops MRTG from taking too long to complete its checks, which prevents the next process from starting. Remember the 5 to 20 minute graphing issues a few slides back? Pictures of text. I tricked you. It's not really a picture. This is what MRTG's cron file looks like after we made our changes. So, where's the pointer? Oh, that is. We have different entries here. I've split each one of the host configuration files into a subdirectory under etc MRTG conf-d. So this was all done by hand, only because it was easier for me at the time to do it by hand, just to get it done as a proof of concept and see if it worked. And it worked, and if it ain't broke, don't fix it, right? There are plans to automate this, and that code will be publicly available. So right now what happens is I've split the configuration files, like I said, manually into different subdirectories, and then each process calls each one of the configuration files under that subdirectory. Now I have individual metrics that I run on each of this to see how long each one of those processes is taking, and they're just into some custom log files that I see when it starts, when it ends, things like that. That way I could keep track. I did it initially so I could see how close it was to that 5-minute mark. You know, this didn't start out as 8 different processes. It started out as 3, and that still didn't work. So it moved on. Now, there's, in additional to these 8 processes, there is one catch-all directory. So when the configuration wizards write to the etc MRTG directory over that NFS, they dump it all in the generic catch-all directory. And then when those metrics exceed 3.5 minutes, then I create another directory. Like I said, it would be nice to have this automated, and that is in the works. I just talked about all this. We split the configuration files into logical chunks by size and created separate cron entries for each of them. The etc MRTG conf-d directory has multiple subdirectories, 1, 2, 3. The naming convention probably could stand to be a little better. I'm aware of that. Like I said, it was a proof of concept thing, and then it worked. So, yeah, we're done. Each corresponding process in cron loads the configuration files present in those directories. So, include MRTG or etc MRTG conf-d and then X, where that corresponds to that subdirectory, the star.conf. I don't know if you guys are familiar. I asked who was familiar with MRTG. In the latest version, they've split that monolithic configuration file approach up. So, before, in the versions prior to the latest release, and forgive me, I don't remember if it's 2.17 or 2.16, if you wanted to include an additional configuration file, that was its own line, and now you can include, based on that, the wildcard.config, and it'll load all those. When they made that change all on its own, when Nagios made that change in the version of 2014 XI, that was really big. It allowed the process to run better. Didn't have to load a giant text file into memory and do all the things that it does. And like I said, we measure each one of those processes separately, and not just the metrics for runtime, errors, standard output, and then the regular logs, and that all is dumped into an MRTG log file corresponding to that process number. We did some other things too. We installed and offloaded Smokeping. Not only did we offload Smokeping, if you think back to the map, all those different areas, we have Smokeping slaves in different geographical regions of the state so that we can get a better idea of ping loss, latency, things like that. I created a Smokeping Nagios XI component to increase the visibility of our graphs in our NOC. I'll get to that picture in a minute. It's like an auto-rotating, it parses the Smokeping URLs for those, and it just shows you the graphs. So, with ours, we know about where the latency is supposed to be, and as those things rotate, we can see if they spike. We built a portal to Smokeping for a particular client to log in and check their own device health, and we created a ModGearman Nagios XI component to manage our servers from a central location. So here's the Smokeping component. Again, I had to black some information out. This component keeps our gateway graphs up at all times so we can keep an eye on them. This is literally on the wall 24/7 in our network operations center. The guys, the engineers can see it, and they definitely use it and can tell, those spikes, these aren't supposed to change. These customers' latencies need to stay exactly where they're at. So any one of the little spikes is enough to look at that circuit and see what's going on. Here's the portal. I obfuscated the text so that I didn't have to black it out. With each one of the Smokeping slaves, we consider that a zone. and each one of those zones has multiple circuits. This particular client has, I want to say, somewhere in the vicinity of 300. And they need this on their network operations center so that they can have some insight into the status. These are all green. That's good. I'm really glad that I didn't get a picture with a red one, because that would have meant that I probably would have had to work for a couple more hours. It would have meant something was wrong. So they have this on their wall, and this scrolls the zones across the screen. If something goes down, it turns red, and if it turns red, the little button that's in that particular circuit, they can click on, and it'll ping that circuit, and they can see what the deal is, what percentage of packet loss is causing this to be reported as down. If it's 100% packet loss, you know, they're going to pick the phone up and they're going to call us and see what's going on. It's really nice. This actually, making this stopped so many phone calls from this particular client, because they have their own insight into their network health. You know, they get to see what we get to see. So the ModGearman component, I wrote it. Laziness is the necessity of invention, and I was really tired of having to SSH into each one of our ModGearman installations, the workers, and reconfigure things if I wanted to change queue size or service queues or anything like that. So I wrote a component that, for one, shows the Gearman top output, and I can see what's running right then, right now, and that's every second. It does a, forgive me, I forget the command line. I think it's a -B, Gearman top, and that just prints it to the screen and exits. So I just run that through an AJAX call in the component. And then we have the ModGearman, the workers, each one of the configurations. So all these things are specified in the component. If you read the code, I did a pretty good job of commenting it so you can follow along and see what's going on there. You specify your IP addresses. You have to set up some Apache SSH keys so that Apache to Nagios SSH keys, I'm sorry. So it uses the Nagios user on the ModGearman, assuming that you set all this up with the publicly available script from Nagios. They have a setup script that you can use and run. The first version, I don't know if any of you guys got a chance to use this thing ever. The first version that I submitted to the exchange had some pretty major security issues. We run on a private network, and I'm going to say this on stage. I'm probably going to regret it. SSH keys over root probably wasn't the best idea in hindsight. I did it as a proof of concept, and it worked, so I didn't touch it. I got some emails from some guys who I got to meet here during this conference, actually, and they had suggested what to change, and I made those changes. So now it's a lot more secure, how it generates the SSH keys, how it gets them to the boxes, how you set up the password for Nagios on the ModGearman installations. So I really encourage you to check it out if you have a ModGearman installation, even if you've only got 2 workers, or I mean, we're running 4 workers right now, and this makes that configuration a lot easier. What did we learn? I think I'm way under the 40-minute mark here. Nagios XI can be extended far beyond its default behavior, which I think a lot of you guys know. Custom configuration wizards, plugins, and components. At the developer meetup that went from 10:30 to 12:30, one of the things that I brought up was the documentation for things like configuration wizards. It wasn't there, and there's documentation. I don't want to say that, but it wasn't very intuitive for what I wanted to do, and I know that we took it a little farther than I think a basic or even an intermediate user will. But some of that stuff needs to be available. My configuration wizards, I start with a template with everything that I learned in the first processes of getting that stuff done. I wrote a template so that I can just go back in and I can add the OIDs and the manner in which they're displayed on the screen. I think that I don't know how soon, but in the near future, that's probably going to be publicly available on the exchange. I've talked to a couple people here who think that would probably be a pretty good idea for their installations. The custom MRTG installations and scans used in the config wizards. So, you know, the MRTG command line that generates the config maker, all that. What is it, config maker? I don't even remember. Port description, all that. All those things can be changed, and in the default configuration wizard, at least the last time that I used it for the routers and switches in Nagios XI, it couldn't be. And I made that possible, and it really wasn't a lot of code. If you dive into it, you can see it, copy it, and use it on your own. I would be happy to assist anybody with that because it is relatively easy. I/O will become an issue, and it should be planned for. We should have planned for it. We didn't. We learned. Well, I just was talking about how to build a process for creating customizations. You know, the configuration wizard customizations, the component customizations. So, you know, we run a few custom components. The maps are probably the most used component that we wrote. And then the Smokeping, and then the ModGearman. And what's really cool about that is when I have an idea for proof of concept, I have those templates already present. And those will probably be made available with the configuration wizards with some decently commented code, I imagine, to let you know what's going on where. If you've ever tried interfacing with the object model in the configuration wizards, it's not intuitive on how to do that. A lot of trial and error. Offload what you can. MySQL and offloading NDO is in the works. MRTG, Smokeping, we offloaded all that so that the throughput on each one of the machines was utilizing maximum that it could for better performance. What's next? Like I said earlier, automating the MRTG process splitting, releasing a generic and well-documented configuration wizard template. And we definitely plan to continue and grow our current installation. There are some pretty big things that we're working on. Right now, just to give you an idea, one of them, we have some custom inputs coming in out of an Arduino, and we're going to try and do some passive checks on, we'll say temperature. It's not temperature, but I don't want to go any farther than that. How to get that stuff back to a Nagios installation and spread it statewide. Questions? Do you have any?
So I'm just curious if I/O and the architecture of the actual Nagios host itself was such a concern. Was there a reason why you didn't just turn up new Nagios hosts to monitor, say, the different sites or the different zones, and maybe tie it together with Nagios Fusion for the display capabilities?
I've learned a lot more about what's available to me just in the last 3 months. And at the time that all this was being developed, I wasn't aware of those as solutions.
Fair enough. Thanks.
Yeah, just to tag on to the first gentleman's question, with the recent release of 2014 and the improvement in performance, do you see leveraging that or scaling back on the ModGearman, or have you felt, any improvements in performance of using 2014 in your configuration?
It's definitely gotten better. The performance has increased as we've upgraded, each one of those minor versions from 2014. I think we're running 1.4 right now. I'm not going to scale back ModGearman because it's working. There are some issues with ModGearman that happened after they upgraded to Core 4, and so getting all those things working was actually pretty tedious. I was alerted yesterday that a lot of that stuff has changed now, that they have put some man-hours into getting their ModGearman packages properly working. I think until an upgrade forces me to either scale them back or reinstall, that it's probably going to sit how it sits.
I'm also curious to what is your average period check time, given that that's on that size of a box and all those hosts?
Service checks are 5 minutes and host checks are all 2 minutes.
One thing to note too, a lot of the modifications that Bryan made with improving the performance of a single server, even if you do intend to deploy multiple XI servers, the performance improvements that Bryan was able to make, you can still utilize that, and your overall infrastructure, even if you have 4 XI servers, for example, if they're really well tuned, you can monitor even more with that, the total 4 once they're optimized. Nice work.
Thank you.
Any additional questions? All right, how about a nice big round of applause one more time for Bryan Heden. Thank you so much,
Thanks, guys.
Bryan.